Hey guys, welcome back to week 2 of my journey with Arduino. We have a lot to cover in this video, so let's get right into it. So, just to give you a walkthrough of the topics we'll be covering in this video. So, we'll go through the difference between analog pins and digital pins. We'll build a basic voltmeter. I'll give you an explanation for some new commands, and then finally, I'll be explaining what a potentiometer is, and we'll be building a dimming LED using a potentiometer. So as you can see, we have something new over here this time around. This is our potentiometer. I'll be going over what this is, the components and everything in a while. So let's get right into it. So our Arduino here, actually, if you can see, we have two types of pins. We have analog pins, which is these marked with A and then the number, and then we have digital pins where we can see from 0 to 13. Those are digital pins. So basically, the difference between analog and digital pins is that analog pins only have two settings, which is high and low. As in, they can only output either 5 volts or low 0 volts, as we've covered in the last video. But using analog pins, we can actually output any value of current between those 5 and 0 volts as well. So how that works is that we don't actually get to output, let's say 2.5 volts. 2.5 volts. It works like our voltage is high for some time and low for some time. So as you can see in this graph that I've built with voltage against time. So let's say if we want 2.5 volts. So our Arduino will actually keep our voltage at 5 volts for some time, and then 0 for some time, then 5 for some time, and 0. So what this will do is it will make our average voltage to 2.5 volts, and this happens so fast that we can't even tell. So using analog pins, we can actually use any voltage between 0 and 5, and it will just figure out the configuration of the time and everything. Secondly, there's also a few type of digital pins which are called PWM pins. So as you can see, a few pins are marked with this weird squiggly sign. So what PWM means is pulse width modulation, which means that it allows for voltage between 5 and 0 volts. So they basically work as both digital and analog pins. Okay, so now that we know what digital and analog pins are, we'll get right into building a voltmeter circuit. Okay, so let's see, we have our Arduino here. So let's see, if I put one jumper cable into this 5 volt, okay, and then I put it into my breadboard, I put a wire connected to here, and then I put the other one into an analog pin. So A0, which is the one I've put it in. Okay. Oh, never mind. It's A1. So I'm worried that this will actually fry my Arduino, but that actually won't happen, as I'll show you guys in the next section. We'll write code so that we see that our Arduino is displaying 5 volts. So we'll get back into it. Yes. So now we'll actually write the code so our Arduino works as a voltmeter. But before we get into that, I'll have to introduce you guys to two new commands. So I'm just commenting here. So we're talking about serial monitors. Yeah. So that's actually a section here in the Arduino. So I'll get into that. So we're going to use two new commands. We're going to use serial dot begin and serial dot print. So basically, Serial.print is basically your Arduino just printing something on your computer. And serial.begin is it basically uses something known as a baud rate. That's baud rate. So that's basically the rate at which your Arduino sends information over to your computer. There's not much you need to know about this. It's not very related. So just know that the maximum baud rate is 9600, which is what we're going to be using. So we'll see results of what we're doing on our Arduino reflected on our computer almost instantly. So let's get into it. So since I mentioned to you guys last time that this is just like C++, which is just a normal programming language, we can actually use variables as well. So I'm actually going to declare our pin A0 to become an integer variable, A1, sorry. So since we used a red wire, let's just say red wire for the sake of convenience, and we'll do A1. So this tells our ID that we have connected it to analog pin 1. Now in setup, we're just going to use pin mode and we'll do red wire. We can just use our variable name and we'll do input since we're using it as input to see the amount of voltage that's being transferred. And we'll use serial dot begin 9600. Sorry. Yeah. So that's that. And then in our loop section, we'll use serial dot print. But we'll use, okay, serial.print, and then we'll use a command called analog.read. So last time we used digital read. Now today we're going to use analog read since we're using analog pin. That's not very complicated, and we'll just do red wire. Now the reason we're using analog read is because we need to actually read the data and then print it on our computer that the ID is Arduino is sending. So once I connect my Arduino, which is what I'm going to do now, I should be able to see that uh, there is 5 volts reflected on the computer. So let's see. So what we see here is 1023. That isn't actually 5 volts, but it is correct. And it is technically 5 volts. So we'll get into that in the next section. But this is basically how you design a voltmeter circuit. Okay, so getting into why 1023 was correct, even though it didn't explicitly say 5 volts, is because our Arduino has a 10-bit analog to digital converter, which means that it can convert analog values, which is any integer between 0 to 5, to digital values at a rate of 10 bits. So with 10 bits, you can actually make 1024 unique values, which is 2 to the power of 10. So since that's the maximum combinations you can make, that's assigned to the maximum voltage of 5 volts. So any voltage between 5 volts and 0 volts is also assigned respectively to any amount of bits such as 2 to the power 2 or 3 or 4 or whatever. So that's basically how our voltage is going to be outputted onto our IDE. So now getting into our potentiometer. Let me just get this to the side. Yeah. So this is our potentiometer, and as you can see we have 3 pins over here. So the center is basically, so this is resistor number 1 and this is resistor number 2, let's say, and this is the voltage out. So, and this is a dial that we have here that we can shift. So if we have this all the way to the left, then the resistance of the one on the left will be maximum and the resistance on the one on the right will be 0. And as we shift, the resistance will get divided amongst these two resistors. So the total resistance of these two resistors, since they're connected in series, it's just the addition between both the resistances, and it always adds up to the total resistance, which we're just going to call RF, or reference resistance, for our purposes today. So we'll just turn the dial all the way to here, And now we'll see how our potentiometer actually works. Okay, so we have our Arduino over here, and let's use one cable and put it into A1 in here. We have one cable connected to resistor number 1, and we'll connect one to the center, which so we have one going from 5 volts connected to resistor number 1 to the center. We'll connect the center one to our pin A1, and we'll connect the third one to our GND, or the negative terminal. GND. Yeah. So now when we go onto our IDE, we should be able to see that as we shift the dial of the potentiometer, the output on the screen changes. So I'll see you guys back with the IDE. Yep. So we're back here with our IDE, and we can see that once I connect my USB, we are seeing the normal usual 5-volt output, and as I turn the dial to the left, you can see that our voltage is decreasing, and then as you keep shifting the dial, yeah, so that's how our potentiometer is going to work. So now you can see where this is going. Like I said in the beginning of the video, we're going to make a LED basically dim and got dimmer and brighter using a potentiometer. So let's do that next. So we have our old circuit here, and all we need to do to connect the LED is to connect the positive terminal, which is the longer one, at the center of, so basically the center pin of the potentiometer, and then connect the negative pin at the GND. Let's do that here. Okay, great. Yes, so now once we connect our, yeah, so as you can see, once I turn the dial, hopefully, yeah, you can see the LED gets dimmer, and if I turn it the other way, it gets brighter, dimmer, brighter, dimmer. Now this is important to know that we need to connect the LED, the positive terminal, at the center, not at the either ends, like the left or right, because we're changing, when we're turning the dial, we're changing only R1 or R2, but the reference RF always stays the same. So we need to actually connect it in the center for us to actually see the effects of us turning the dial. So yeah, that's it for this video. I'll see you guys next week.